Hi guys, just going to see if I can do a talk through to explain this circuit that I've put together on Tinkercad to simulate the circuit in the solar flower pot that I took apart. It's got a little circuit board there with two transistors on it. If I just move my cursor around, so we got two transistors, they're both NPN transistors. There's four resistors. 39 kilo ohm, 100 kilo ohm, 10 kilo ohm, and 18 ohms. So those are the ones that are actually on there at the moment. Then we got a diode there. Then I've got a single LED there to represent the string of LEDs that are on the flower pot. I say string, I think there's 9 of them, and there's actually a little circuit board associated with them that cycles through the red, blue, and green colors, but we're not interested in that here. Down here, I've got two battery packs. The one on the left represents the solar panel, and the one on the right is the nickel metal hydride rechargeable batteries. And I've got two displays to show us what the voltage is, and then I've intercepted the circuit and put these little slide switches in place so I can demonstrate disconnecting parts of the circuit. So if I start the simulation, you see we've got 4.5 volts from each of the battery packs, and the LED is not on. So what we're looking at here is the nickel metal hydride batteries are fully charged at 4.5 volts. It should be 3.6, but we won't worry about that. 1.2 volts each. And the solar panel is in full sunlight and also giving us 4.5 volts. And what happens there is nothing on the face of it. And the reason nothing's happening is the power is coming from the solar panel, and it should be going to the nickel metal hydride batteries, but because they're showing fully charged, we see the 4.5 volts. If I switch them off, you'll see we've got a bit of a volt drop. We've got 4.5 volts coming in from the solar panel, and then we got that diode in circuit before it gets to the nickel metal hydride batteries. So that 3.9 volts we're seeing there is the 4.5 volts from the solar panel minus the voltage drop across the diode. So if we follow the positive from the solar panel, we come up here through the diode, down there to the nickel metal hydride battery. And then if we go back on the negative from the nickel metal hydride battery, we go direct to the negative of the solar panel. So while the batteries are low, the solar panel will be charging them. And there's no light on the LED. If we switch the nickel metal hydride batteries back on, indicating they're fully charged, and it goes dark, so we'll switch off the solar panel. So we've got no volts from the solar panel, 4.5 volts from the nickel metal hydride batteries, and the LED is on. You may notice that. I'll just switch that off and on just so you can see. So sunlight on the solar panel, 4.5 volts, switches off the LED. The reason we're doing this is that at the moment, when there's sunlight on the solar panel, the LED switches on, which it shouldn't do. what should happen is the transistor on the left should switch off the transistor on the right to prevent the LED coming on. So, off, LED on, off, LED off, so there's no power anywhere. Solar panel on, LED is still off. If any of the legs that go to that transistor are faulty, so if I break the circuit here, LED comes on. Put that back again, break the circuit here, LED comes on, back on again, break the circuit here, LED comes on. So I'll just explain that again. Solar panel is on, nickel metal hydride batteries are off, but if the transistor on the left isn't working, the LED comes on and it's being powered direct from the solar panel. So what I need to do now is go back to the circuit board and check each of these resistors and the wires going to that transistor and that transistor. Right, I've just had a little thought there. I've added a switch in just there, a slide switch just there, so I can disconnect the diode just to demonstrate the power going from the solar panel to the nickel metal hydride batteries. So if we start the simulation, LED is off, switch off the solar panel, LED is on, switch it back on again, LED goes off, switch off the nickel metal hydride batteries, and we can see the power back feeding from the solar panel to the nickel metal hydride batteries. And if I switch or disconnect that diode by throwing that slide switch there, then we got no power going to the battery. So that tells me that that diode is okay. Things are working there, even though it looks particularly rusty on the circuit board. If we connect that again, disconnect that transistor, LED is working. If we disconnect the diode, the LED goes out. So that tells us that the diode is okay, otherwise the LED wouldn't be alight when there's power on the solar panel. So we know that part of the circuit's okay. It's got to be one of these resistors or that transistor. Hope that covers it. I think I did all the variations there that we needed. I'm sure somebody will add a comment somewhere that I missed one variation there, but I think I covered them all. That side, that disconnects the base by throwing that one. That disconnects the collector by throwing that one. And that one disconnects the emitter. That'll do. So thanks for watching. Don't forget to like and subscribe. Leave us a comment so I know how I'm doing. And somewhere up here there'll be some links to related playlists. Thanks again.